Hello friends, good morning. Myself MB Gaddi, lecturer in EC department. Today I am going to discuss regarding Unit 2 digital coding of analog signals, some important question banks. First question, define quantization and quantization noise. It is for 5 marks. Quantization is the process of converting a continuous range of values into a finite range of discrete values. This is a function of analog to digital converters which create a series of digital values to represent the original analog signal. The quantizing of an analog signal is done by discretizing the signal with a number of quantization levels. Quantization is representing the sampled values of the amplitude by a finite set of levels, which means converting a continuous amplitude sample into a discrete time signal. This is for 2 marks or maybe 3 marks. And one more definition, quantization noise. This is one of the type of error that can be introduced an analog signal when it is being encoded into a digital form. Quantization noise is typically caused by small differences, mainly rounding errors between the actual analog input voltage of the audio being sampled and the specific bit resolution of analog to digital converter being used. Mention advantages, disadvantages, and applications of PCM. Advantages of PCM: pulse code modulation. The PCM convenient for long distance communication. Second one, it has higher transmitter efficiency. Third one, it has higher noise immunity. Disadvantages: it requires large bandwidth as compared to analog system. Encoding, decoding, quantizing circuit of PCM is very complex. Applications: it can be used for wideband communications, channel store cum bandwidth problem. With the help of data compression along the PCM, the redundancy can be removed and data rate can be reduced. One more question. Write a note on compending process. Compending Compending refers to a technique of compressing and then expanding or decompressing an analog or digital signal. Figure shows the compending diagram: output voltage versus input voltage, compression, expansion, and linear characteristics. It is a combination of two words, compressing and expanding. This is twin sequential process is non-linear overall but linear over short periods of time. Data compressed before being transmitted. Compending refers to a technique for compressing and then expanding an analog or digital signal. It is a combination of the words compressing and expanding. This twin sequential process is non-linear overall but linear over short periods of time. Data is compressed before being transmitted. Mention merits, demerits, and applications of data compression. 5 marks. Merits: transmission rate and data size are reduced. Second one, storage capacity is reduced. Third one, transmission bandwidth is reduced. Fourth one, portability of information is increased. Next point, that is demerits. First one, some information is lost. Second one, distortion is introduced in a reconstruction. Compression and decompression algorithm are complex. Applications, storage and transmission of image and video data. Second one, analysis of storage of speech data. Third one, storage of documents. Next question, mention advantages, disadvantages and applications of bipolar signal. It is for 5 marks. Advantages, no DC components. Second one, occupies less bandwidth than unipolar and polar RZ schemes. Does not suffer from signal drop. Third one, possesses single error detection capability. Disadvantages, does not possess any clocking component for ease of synchronization, is not transparent. Applications, small data networks, PCM data transmission. Describe RZ and NRZ unipolar signaling formats with waveforms. 5 marks. Unipolar non-return to zero NRZ. Duration of mark pulse tau is equal to the duration T0 of the symbol slot. Figure shows if it is a transmitted information, it can be represented as a 1. Non-information, it is a 0, that is mark and space. Unipolar return to 0. Mark pulse tau is less than the duration T0 of the symbol slot, fills only the first half of the time slot, returning to 0 for the second half. The figure below shows the transmission of unipolar return to 0. Describe RZ and NRZ bipolar signaling formats with waveforms. It is a bipolar NRZ. In this format, successive pulses with alternative polarity and zeros are represented by no pulses. Bipolar RZ. Figure shows bipolar RZ. In telecommunication, bipolar encoding is a type of return to zero RZ line code where two non-zero values are used. Describe RZ and NRZ polar signaling formats with the waveforms. Polar RZ, a binary 1 pulse, G1 of t, a binary 0, the opposite or antipodal pulse G0 of t equal to minus G1 of t, fills only the first half of the time slot, returning to 0 for the second half. The figure illustrates RZ and NRZ polar signaling format. Polar non-return to 0. In polar signaling, a binary 1 is represented by a pulse G1 of t and binary 0 by the opposite pulse G0 of t equal to minus G1 of t. Polar signaling also has NRZ and RZ formats. Describe briefly Manchester format with waveforms. Manchester signaling. Figure illustrates Manchester signaling. The duration of the bit is divided into two halves. 1 0 is positive in first half and negative in second half. A 0 is in a negative in first half and positive in second half. Advantages: no DC component, does not suffer from signal droop, easy to synchronize, is transparent. Disadvantages: Because of the greater number of transitions it occupies significantly a large bandwidth, does not have error detection capability. Name the types of quantization technique. There are two types of quantization: uniform quantization and non-uniform quantization. The type of quantization in which quantization levels are uniformly spaced as a uniform quantization. The type of quantization in which the quantization levels are unequal and mostly the relation between them is logarithmic is termed as non-uniform quantization. There are two types of uniform quantization. They are mid-rise type and mid-trade type. The following figures represent two types of uniform quantization. Figure 1 shows mid-rise type uniform quantization. Figure 2 shows mid-trade uniform quantization. Then one more figure which shows example of the non-uniform or third bit quantization. Explain the block diagram of pulse code modulation. It is for 10 marks. It consists of blocks: low pass filter, sampler, quantizer, then encoder used for PCM transmission. Then distorted PCM signal can be recovered by regenerative repeater. That is, regenerated PCM signal passed through regenerator, decoder, low pass filter, then it will be goes to receiving unit. Definition: a technique by which analog signals gets converted into digital form in order to have signal transmission through a digital network is known as pulse code modulation. It is abbreviated as PCM. PCM systems are basically signal coders, also known as waveforms. PCM representation of the continuous time message signal as a sequence of binary coded pulses. The binary form permits only two probable states, that is 0 and 1. The major steps involved in PCM is first one, sampling, quantizing and encoding, which will be given in the explanation. In pulse code modulation, the analog message signal is first sampled and then the amplitudes of the sample is approximated to the nearest set of quantization level. This allows the representation of time and amplitude in a discrete manner, thereby generating a discrete signal. This discrete signal is then converted into its binary form for the transmission of the signal. It is to be noted here that PCM techniques, the signals get transmitted in the coded format and must be decoded at the receiver in order to have the original message signal. Figure shows block diagram of PCM pulse code modulation system. Explain briefly delta modulation technique with block diagram. Below figure shows delta modulation transmitter. The sampled input will be given to the summer. The output of this error ENTS given to 1 bit quantizer. The output of that is given to one more summer. Then delay second will be given to delay second. Again it will be feedback. The combination of summer plus delay TS is called the accumulator. Figure shows the transmitter. It is also known as delta modulator. It consists of a 1 bit quantizer and a delay circuit along with two summer circuits. The summer in the accumulator adds quantizer output plus or minus delta with the previous sample approximation. Receiver. Figure below shows the receiver. The input is applied to the summer, then again it will be given to the low pass filter, then the delay ts will be there, it is again given back to the summer. At the receiver end, also known as delta modulator as shown in figure, it comprises a low pass filter LPF, a summer and a delay circuit. The predictor circuit is eliminated here and hence no assumed input is given to the demodulator. The accumulator generates the staircase approximated signal output and is delayed by one sampling period Ts. It is then added to the input signal. If the input is binary 1, then it adds plus step to the previous output which is delayed. If the input is binary 0, 1, then one step delta is subtracted from the delayed signal. Also, the low pass filter smoothens the staircase signal to reconstruct the original message signal x of t. From low pass filter, we are going to get demodulated output. Mention merits and demerits of delta modulation. Delta modulation transmits only one bit or one sample, thus signaling rate and the transmission bandwidth is quite small. Second one, transmitter and receiver implementation is very simple. Demerits: slope overload distortion, that is startup error. Second one, granular noise, that is step size too large. Describe briefly DPCM system. It is for the 8 marks. Below figure shows DPCM system block diagram. The sampled input is given to the comparator, then output is given to quantizer, that again it is given to the encoder, then quantizer output EQNTS is given to summer, the summer output is given to prediction filter, again it will be given back to the comparator. The below figure shows DPM transmitter. It consists of comparator, quantizer, prediction filter and a decoder. The sampled signal is denoted by XNTS and predicted signal is indicated by XNTS. The comparator finds out the difference between the actual sample value XNTS and the predicted value XNTS. This is called signal error and is denoted by ENTS. ENTS equal to XNTS minus XNTS. Here, predicted value XNTS is produced by using prediction filter using signal processing filter. The quantizer output signal EQNTS and the previous prediction is added and is given as input to the prediction filter. This signal is denoted by XQNTS. This makes the prediction closer to the actually sampled signal. The quantized error signal EQNTS is very small and can be encoded by using small number of bits. Thus, the number of bits per sample reduced by DPCM system. Below figure shows receiver of DPCM. In order to reconstruct the received digital signal, the DPCM receiver is shown in figure consists of decoder and prediction filter. In the absence of noise, the encoded receiver input will be the same as the encoded output. The predictor undertakes value based on the previous outputs. The input given to the decoder is processed and the output is summed up with the output of the predictor. To obtain better output, that means here first to all the decoder will reconstruct the quantized form of the original signal. Therefore, the signal at the receiver differs from actual signal by quantization error Q of NTS, which is introduced permanently in the reconstructed signal. Mention merits and applications of DPCM. Bandwidth requirement of DPCM is less compared to PCM. Quantization error is reduced because of prediction filter. Applications, it is used in audio data compression techniques. Describe briefly distortion in delta modulation. First one, slope overload. When the analog input signal changes at a faster rate than the DAC can maintain, the slope of the analog signal is greater than the delta modulator can maintain and is called slope overload. Figure shows analog input, steep slope, rapid change, then DAC output. Second one is granular noise. It can be seen that when the original analog input signal has a relatively constant amplitude, the reconstructed signal has variations that were not present in the original signal. This is called granular noise. Granular noise in delta modulation is analogous to quantization noise in convention PCM. Compare different pulse code modulation system. This is for 5 marks. The table shows first parameters PCM, DPCM, delta modulation and ADM. Now we'll see the difference one by one. Number of bits per sample in PCM 4, 8 or 16 bits. In DPCM more than 1 bit but less than PCM. DM 1 bit, ADM 1 bit. Second parameter, number of levels depends on number of bits. Fixed number of levels in DPCM, in DM 2 levels, ADM 2 levels. Next parameter, step size. Concerned to PCM, fixed or variable, in DPCM, fixed or variable, in DM, fixed one, ADM, variable. Next parameter, transmission bandwidth. In PCM, more bandwidth needed. In DPCM, less than PCM. In DM, lowest. In ADM, lowest. Feedback. In PCM, does not exist. In DPCM, exists. DM exists. ADM exists. Quantization, noise or distortion. Quantization noise depends upon number of bits in PCM. In DPCM, quantization noise and slope overload. In DM, slope overload and granular noise. In ADM, quantization noise only. Complexity of implementation. In PCM, it is a complex. In DPCM, it is a simple. In DM, it is a simple. In ADM, it is simple. This is the second chapter, block diagrams and comparators, then the transmitter, receivers. You have to study well, and diagrams carrying maximum marks. You have to prepare for examination diagrams neatly, practice more, and with depending upon the questions, how much answer you have to write, note it for 3 marks, 2 marks, or applications.